Hi, I'm Sonia, and I'm here to talk about the exciting new collaboration between Honey Badger Silver and ExploreTech. Today we have Alex and Tyler with us, two brilliant minds who are changing the game in the mining industry with their cutting-edge technology. Thank you for joining me.
Be here. Thank you.
Yeah, happy to be here. Thanks.
I'm so excited to get to discussing your collaboration. Let's start with something super simple, like what inspired the two of you to start ExploreTech?
Well, so we started Explore Tech because we saw a whole new generation of technology and data science coming out of the lab from our PhD experience. And what we saw was that there's a lot of potential in that technology, but what was missing was the link between the research and commercializing it, making it work for everybody in the industry. And so we essentially started Explore Tech to create that link between the new, latest, and greatest technology and bringing it to everybody in exploration.
Yeah, and you're trying to like modernize it, basically.
Yeah.
Would you be able to explain in like the simplest terms how your geophysical inversion technique works and why it would be important for the Plata project?
Yeah. So the geophysical technique that we've developed was something that I worked a lot on during my PhD dissertation. And so, really, the idea there is to take geophysical data, which companies like Honey Badger already has on Plata, and integrate the geological understanding of that project into the geophysical interpretation. So, what we're able to
Hmm.
do is get quantitative estimates of the shape, size, depth, and location of things like intrusion. So, that's why this is really important at a project like Plata, where this
Hmm.
intrusion can have a big impact on where you're going to decide to target your exploration efforts.
Hmm. Interesting. Okay, so how does it differ from traditional methods?
Yeah, so typically when you collect a geophysical data set, in this case, magnetics, which is at what we have at Plata, is you can do a couple of things to it, but generally you're creating a map and maybe do some corrections for the orientation of the magnetic field to make it more accurate. But you essentially create a 2D map that highlights where bright spots are, or if you go deeper than that, you could do a 3D inversion and get a map of the magnetic properties of the subsurface. But then you're still missing that link with the geology. And so it
Hmm.
takes an extra step to take that 3D subsurface blobby looking map and turn that into something that's geologically meaningful. And that's
Hmm.
really where we come in, is we're able to make that type of data into a geologically meaningful interpretation of that you can use to guide exploration.
Wow, that's incredible. I noticed online that you guys developed a platform called the Engine and the technology called XFlare. So how do these two differ and how do they come into play in your work?
So XFlare is a tool built on top of the engine. And so
Hmm.
engine is the core of our business and is what we use to scale and distribute technologies throughout the industry. And so
Hmm.
XFlare is a product that we built on top of the engine. And so there are going to be many more products built on top of the engine by us and by other people.
Hmm.
Essentially, the engine is what we use to distribute all these great technologies that are made in universities or within working groups so that people can apply these technologies not only on one project, but another and another and another without having to set up the data infrastructure, which takes a long time for every individual project.
Hmm. Interesting. Okay. And so the XFlare is what you'll be using at the Plata project, or both of them combined. Why couldn't you just
Yeah.
use the engine?
The engine um, handles the computing infrastructure. So
Hmm.
the engine is what takes care of spinning up the computing resources, putting the simulations onto the computers, saving the data to memory, reading the data from memory. The engine takes care of all of the heavy lifting on that side of it. And
Hmm.
then Xflare is the application-specific code that's written on top of the engine that actually does
Mm,
the interpretation of the data.
okay. Okay. That's very interesting. So, how does the cloud computing come into play in your work?
So the cloud comes in because we have to perform a lot of computations very, very rapidly. And so at a technical level, what we're doing is we're doing a forward simulation of a geological model. And people have done that a lot throughout history. You
Mhm.
know, over the decades, people have done forward simulations of geological models, but they haven't done them hundreds of thousands of times like we do them.
Mhm.
And so that's the main problem that we're solving with cloud computing is how can you perform hundreds and thousands of computations in a very fast manner so that you can update geological models during an exploration program.
Yeah.
And so that's one of the main problems that we see in the market right now is that many of these new successful technologies require a lot of cloud expertise and a lot of cloud computing.
Mhm.
And those two problems really aren't solved in the mining industry the way that we solve them.
There's multiple things going on here. The cloud computing is just one part of it, right? People
Right.
still have to write good algorithms to make sense of geological and geophysical data in a way that addresses the nuances of the data sets that we work with in geology. And a lot of the big tech algorithms that you see a lot, so like ChatGPT is trained on a ton of data. We don't have that
Mhm.
luxury in exploration companies, especially not in junior exploration companies. And so we
Yeah.
need approaches that are able to handle the data sets that we do have in ways that aren't, bringing a tool that was built for something else and just kind of forcing it to fit on a data set that a geologist has. And so,
Mhm.
there's the computing side, there's the algorithm side, and then, there's some amount of, learning in the industry about how these tools are going to be best used, and we're still, learning as well about how these things are useful in practice. And so there's a lot to do here.
Yeah,
Yeah.
and building off of what Alex said, that's our new view on how to apply AI technologies in mining and mineral exploration. It's not just
Mhm.
taking whatever's developed by big tech companies and then translating them over to mining and mineral exploration. It's two
Yeah.
fundamentally different problems, where one is really, really big data, and then another is small data but highly cleaned. And so, how do we use technology to address small data problems that require cloud computing, right? And so,
Mhm.
it's like what it comes down to is you have these problems in big tech, which have a massive amount of data and different solutions built for them. Those solutions
Mhm.
don't translate over to mining and mineral exploration in the way
Yeah.
people think they would.
Mhm. Well, it's incredible to see technology just making such a huge impact. Every week is something new. It's
Yeah,
insane. It's insane. I
yeah,
can't even keep up with it.
Every
And
week
that's
so
just,
is
exciting.
yeah.
Yeah,
every
Wow.
week is something new. And the main thing,
Scary.
like the rapid pace of technology event, people like to say that the mining industry doesn't have access to good technology. I don't think that's really correct. I think the pace of technology adoption in the mining industry is actually quite rapid. If I remember back, 10 years when I started my career in the mining industry, what I had at my disposal, the tools that I had, compared to right now, it's rapidly different, and that's true for many industries. And I think
Yeah.
mining and mineral exploration get a bad rap for not being as advanced. The amount of change has been pretty significant.
So AI is actually helping your business tremendously, right?
yeah. So the things that we're doing wouldn't be possible without all of the advances in GPU computing and neural network architectures and the software for building neural networks really fast. Like all of that is like at the core of what we do. It's just that we're combining that in different ways that don't look like ChatGPT.
And that's like what it comes down to is like, how do we identify what has been developed in the broader industry and translate it to mining and mineral exploration in a way that makes sense for the kinds of problems we have in mining and mineral exploration. There's all sorts of great stuff being developed by Google and Facebook and Microsoft and OpenAI and Anthropic and beyond. But all of those technologies are not necessarily best suited for mining and mineral exploration. We're identifying the ones that are really well suited for it, and we're building products that combine all of those on top of the engine, which can then scale those products through many different customers very, very rapidly. And so Honeybadger is just one customer that we're interacting with and deploying xFlare, which is this first product.
Okay, so how do you guys see the future of mining changing with these technologies? Like, where do you see mining going forward?
That's a great question. I don't know if I'm going to be right in any predictions here, but I'll give it a shot on what I'm excited about at least. And we really see the entire stack of mining is going to be affected by this. So when I say stack, I mean everything from like early stage exploration to like mine optimization. And the big thing that we see being unlocked is the ability to ingest data, update models and understanding quickly, that in a way that integrates lots of different data sets, and then automate recommendations on top of that as well. So instead of, for example, like in exploration, this is kind of what we're doing with Honeybadger. We can get a drill target from just a blob on a geophysical map. We can turn that into a quantitative drill target with a drill hole in a fraction of the time that it would take to do this with kind of traditional workflows of doing an inversion and having a back and forth discussion. We can just integrate all of our knowledge and our data immediately, get to a decision super fast. That same concept could translate all the way into mining operations as well, where you have, you know, data coming in from all sorts of different sources as you are, you know, operating the mine and collecting data, and you can be quickly updating your models and the decisions that you would make on those models rapidly. And it's not to say that like the AI is going to be making all of the decisions, but it can put a few candidates in front of someone so that they can spend more time thinking about which one of these candidates is the best, and not like, how do I even formulate what the best one is?
It's going to be crazy. It's going to be a crazy world.
Yeah.
Literally, what was it, 3 years ago? No, 2 years ago. When did ChatGPT come out?
2022. I think it was like first like pre-released in 2022 or something like that.
I remember I was doing something on Discord where you can make these crazy photos. I'm not sure if you know about that. Oh my God, it was incredible.
The best
thing, look where we are.
Yeah.
It's getting crazier.
Best thing that I see about AI coming up is it will be able to recommend you many different options of what to do, and then you go ahead and select from those options, right? Generating those options and creating those options takes a lot of effort for people to do. And so the power of AI is that it can go ahead and generate you 100 of them, and then you can go ahead and select the best ones, right? And so if you use ChatGPT today, if you directly copy and paste those outputs into your email, into whatever, it's probably not the best, but it'll give you a really good place to start. There's still some level of expertise, of course, that you'll need to be able to identify what's good and what's bad. What's a good drill hole? What's a bad drill hole? But to be able to assess those recommendations under many different scenarios, what if I could only drill one? What's the best one? What if I could only drill 2 boreholes or 3, 4, 5? It can generate you all sorts of plans like that. And then you go ahead and select the one that fits with your geological constraints or operational constraints.
I don't know. I'm scared to see what the future holds, honestly.
I think
I'm excited, but scared.
Yeah, it's I think it's interesting because there's a degree of like, you know, excitement that people want to drum up And like that excitement ends up being like, oh, we should be scared, right? Because that scared sort of thing, that fear, people, that's an emotional thing people respond to much more than optimism in the future and happiness and so, but the thing is like right now I'm very optimistic with how things are moving and the types of efficiencies and better decisions we'll be able to make with AI. I don't think it's a scary thing. That's just my viewpoint on it. It makes me actually pretty happy because I think we'll be able to end up discovering a lot more mineral deposits and operating a lot more efficiently rather than what we're doing today. So,
what are some key challenges that you've come across when you've applied your computational methods to real-world mining projects?
Yeah, so there's a few. I think one of the big ones is, how do I know my geology is right? So if we're talking about this kind of XFlare approach that we've developed, it requires some amount of geological expertise to go into it. And the way that we represent that geological understanding is through simplified shapes. The technology will get better over time. We'll be able to use more complicated shapes, but regardless of the complexity of the shapes, you have to know roughly what it is that you're looking for. And so one of the key challenges that we find is that you might think that there's an intrusion there, but in reality, it's graphite or some sort of magnetic, dike that's not really interesting. And so you're still getting roughly to the source of whatever's creating the anomaly that you're looking for, but it's not what you think it is. And so the fact that you have to have that geological understanding at the beginning, a real challenge to develop, and then to reconcile once you actually drill and find something that isn't what you expected to be there. So that's one of the big challenges that I see. So obviously, like, it's not a silver bullet, but it can be super effective in getting a first order approximation, and at least it's a way to test the idea. And so you're not just going to be guessing, like, is it this, maybe it could be this. You at least have a way to test that idea, and I think that's what's important, but it's still hard.
Yeah, of course.
One of the reasons that we like the Plata project with Honey Badger is because the intrusion hypothesis is so clear, right? If you were to put up a picture of the hypothesized RERGS type system, right? If you were to put up a picture of that RERGS model, that's a very clear shape with which we can make an ellipsoid and then model the mineralization at the top of the ellipsoid. And so having that understanding from the beginning is really, really helpful, because we've worked with clients in the past who they just say, hey, we don't know anything about what could be below, and we just have to go ahead and drill it. And so for us, we need some kind of guess in the subsurface. We need to know if it's an intrusion which looks like an ellipsoid at depth, or if it's like a sedimentary system. Those look very, very different. We need some kind of input. And so that's why Plata is great, because we have such a clear hypothesis on, we believe this is a RERGS type model, and we can represent that very clearly and then use that representation in XFlare.
Okay. So do you guys have to be at the Plata project to do your work, or you can do it all from the comfort of your office?
It helps us to
do it.
Right. It helps us to go to the site to get an idea of how everything looks in real life, because on a screen you really don't get a good appreciation of the relief of the vegetation, what the rocks actually look like up close. So we do like to visit the site, and we've done that for other clients as well. Like, for example, Prismo Metals, we did a site visit with them. So we like to do that, but we can definitely still complete the entire process from our computers, as long as we have good input from the field geologists. And so that's why we keep that loop very, very tight between field geology and the ExploreTech eyes in the sky, for example.
Yeah. Wow. It's incredible. Congratulations. You guys have had an incredible year. Like incredible. Reina and Prismo. That's fantastic. And now Honey Badger.
Yeah.
It's been exciting to start up because we started in August 2023 and we just hit the ground running. For me, following my PhD, and then for Alex, after he had finished up some contract work. The response that we get from our customers is very positive because we're doing something different and we're communicating about it in a different way. And so with the explorers who are seeking out the newest technology, they really like to work with us because they believe we're formulating problems in ways that they've been looking for the past, ever since AI and data science started to become big in mining and mineral exploration, 8 years ago or so. So it's been great to start up.
So do the results from the Snowline Gold project, do they help you guys with your data analysis, or is it like completely irrelevant?
It gives us confidence in the geological model. We don't actually use that regional data from other deposits to train an AI and predict another deposit. That's one of the main ways that we're different because we don't use quote unquote big data approaches, which trains on a global or even like a regional Yukon data set and then pick out places in a more local area where to drill. We don't do that. Essentially, we're using AI to speed up the computation of traditional geology and geophysics. And that's why we've had very good buy-in from geologists who have very successful track records because they see what we're doing and we're supercharging things that they've been doing for decades. I mean, the way that we do that is using the engine and the cloud. There's going to be many people like us, like Alex and I, who have developed good technologies, but don't have the cloud expertise with which to distribute them. And so that's why we're building the engine. For all the other scientists out there who have inversion and drilling tools, we call them XFlare, right? Yeah. But in their own expertise, this could be for geochemical analysis, this could be for any sorts of things, perhaps not even related to the mining industry, but they don't have the expertise to actually figure out how do I get my tool onto the cloud and how do I distribute it to a company who wants to do it. That's what the engine is used for. So for Honey Badger right now, XFlare solves a problem for them and it solves it pretty well. It's well formulated. In the future, we'll be able to make it not only so Alex and I can solve problems like that, but for other scientists and engineers to distribute their technologies which require cloud computing. In order to solve customer problems.
Yeah, and it's like a fraction of the time too, right?
Yeah, it's getting much faster. Yeah, it's a fraction of the time and a fraction of the cost. We actually put together a cost model for one of our tools last night, and we were shocked at like how accessible it's going to be for people who want to run it.
That's amazing.
Everybody can access it, and it's not sort of gate kept by very expensive and time constrained experts, right? Right now, the way that we're doing it, Alex and I were the experts. We sort of have to manage that, right? But we want to make these tools in a way that anybody can use them. You'll need some level of expertise, but we want to make it so that it doesn't need to be mediated by, for example, a consultant at every step of the way. What that means is it's not like you just generate one result, you write a report on it. People hate to pay for reports being written, right? They would love to be able to run something themselves, modify something. Oh, I don't know about that. Run it again, and run it again, and run it again. That's what the engine can solve, is being able to iterate on geological ideas and hypotheses at a rate that nobody's really been able to see before. And so I think it's going to change the game in the mining and mineral exploration industries.
I think so too. How long does it usually take to like finish a complete data collection from beginning to end?
So the kind of the life cycle here is we come in, there's already data available. That data has been collected. that the original data collection takes a long time and a lot of effort, can be expensive too, or it could be free if it's publicly available. But we come in after that has already been collected. Once we come in, we generally find that there's a process of getting people up to speed on how everything works and what it is that we need. That takes a few weeks, a handful of conversations over a few weeks. Then we settle on an idea of exactly what it is that we're going to do. And then at that point, it takes about roughly a week to go from here's exactly what we're going to do to the result getting out. And generally, it's like a day-ish of getting the models and the data set up. And then it's 4 or 5 days of letting the computer run.
Wow, that's incredible. And traditionally, how long would it usually take?
A geophysical inversion, the standard approaches take similar amount of time, but then where the real time savings from using our type of approach comes is from what happens after you get the geophysical inversion. So typically from a geophysical inversion, that inversion result gets presented to the customer, and then there's a back and forth over a period of a few weeks to a few months of like, this doesn't look good, this doesn't look good, this looks good, oh, this could be this, like now I'm kind of getting it. That back and forth is what we basically cut to zero. So that's where we can save like a few months of this interpretation time.
Mm-hmm. That's amazing. Wow. Well, I'm so excited for you guys. And once again, congratulations on all you've achieved in this year since you guys have started. It's incredible.
Thank you.
And inspirational.
It's been really great. It's been really exciting to be able to sort of distribute the technologies that we've been building during our PhDs and beyond, and eventually give those same tools to the wider industry. And so it's been really great, and thank you for having us on this call. It's been great to talk to you and go through sort of the high level and the details of how we see the future and compare to what's been done.
And we're super excited to be, working with Honey Badger. We love the team, very, very sharp team, and just very professional all around. And the project is super exciting as well, with all so much mineralization on that property.
So much.
There's got to be something there. So I'm excited to see this project move forward.
Before we wrap up, is there anything else you'd like to share about any future projects or about the Plata?
It's www.explortech.ai. If anything that we said today was interesting to you, if you want to build a tool on the engine, have us build something, or you just want to see how it works, you can find us there. You can find us on LinkedIn. Yeah, thank you for the opportunity. This was a lot of fun.
Thank you, guys.